This section is about quantitatively analyzing friction. When there is relative motion between objects whose surfaces are in contact, the force of friction will be called kinetic friction. It's the friction of motion. Kinetic friction has a quantitative formula, Fk equals mu k times Fn. Below are some approximate coefficients of friction for combinations of materials. The coefficient of kinetic friction is on the left, and the coefficient of static friction is on the right. Let's start with a kinetic friction example. A wood block weighing 200 newtons is moved over a horizontal wood surface by a force of 150 newtons applied parallel to the surface. What will be the acceleration of this wood block? So let's do a little diagram of our situation. There's our wood block. Here is the wood surface. Now, all surfaces are not going to be perfectly smooth. And that's what really causes friction. When we're trying to drag a piece of one material over another, then it could get caught up in these little imperfections in the surface. And you can imagine that once that block gets hung up, there could be tiny normal forces exerted on the object. The sum of those tiny normal forces is what we refer to as kinetic friction. But now let's draw a free body diagram for our block on a macroscopic level. It's going to have a weight, and there will be a normal force. The weight, we already know, is 200 newtons. So we know the normal force is going to be 200 newtons as well. There's going to be a horizontal push of 150 newtons. Now what we need to do is we need to calculate the force of friction. The force of friction is going to be directed to the left, and I don't know yet how big it's going to be. I'll call it Fk for kinetic friction. Let's use the formula. Alright, so our mu for kinetic friction is going to come from the table. We're doing wood on wood here, so we need a coefficient of 0.3. And we're supposed to multiply the mu k, the coefficient of kinetic friction, times the normal force. So for our block, that's going to be 200 newtons. And that should make sense, that the more force or pressure there is between the surfaces, the more difficult it could be to slide one surface across another. Alright, according to the calculations here, our frictional force is going to be 60 newtons. Now we want to find out what the acceleration of the wood block will be. So we have to find the net force, and I'll find it by summing the forces. I'll do it with respect to the x direction. Alright, we're going to get negative 60 newtons for the friction, 150 newtons for the push. That's a net of 90 newtons for this block. Then finally, I'll use Newton's second law. Okay, I'm going to have to find the mass of this block. I do see that its weight was given, but not its mass. It's 20.4 kilograms. Alright, now we can finish the problem. .4 meters per second squared.